Okay, the element. So while I was testing to do the software, I connected the element to the AC to put it on to measure the thermocouple, and it would not heat up. Unfortunately, this was a issue that was created by me because I left the wires coming out of the element. They're not designed to be moving about, and that's the issue. I had these connectors here loose, and with this unit not installed in there, normally when that's in there, nothing's going to move, right? Well, it decided to go an open circuit. So that's the actual element itself there, the outer casing, sorry, and that's the element there. You can see the windings. Okay, I have the nichrome wire, which got some fiberglass webbing on it. And you cannot really buy this wire. But this wire is spot welded. It's spot welded. This is the insulation. And you can see it there. Let's see if I can zoom into that. Okay, there's the nichrome wire, and I wonder how many turns it's got. I know this should be around 12 ohms, right? Because it takes 2 amps and it's 24 volts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Looks like it's got 20 to 21 turns, probably. Just a rough counting there. And so this unit, this part, hang on. Maybe zoom out a little bit. Was spot welded to this, and when the wire was open circuit, I actually see if this was loose. I pulled it and this came right out of the insulation part. So I decided, so this unit, zoom more out, okay, slides inside this pipe here, and it's actually pressed in there. I managed these elements, right? They're not made to be taken apart. Once the element goes, normally you just buy a new one. So, but I'm going to try an experiment here. So this unit, okay, fits in here, goes in there, and it presses on of the edge here. Okay, but you cannot solder this because that gets very hot for 100 degrees. It's a soldering iron after all. So that's spot welded, and even if this was able to, if it didn't get hot, you can't solder it because nichrome will not take any solder. So that's got to be spot welded back, those two parts. Okay, this is probably some nickel wire. Okay, so I'm actually going to try. Look, that's the insulator there. That just came out. I know where that goes at the back there. I'm not showing you. That insulator was at the back here where the wires come out. Okay. But what they should have done, they should have put cement here Okay, so I'm not really happy with this. So this part cannot be pushing all the way to where the element is. You know, not just a packer, a bit of fiberglass insulation. They should have put some sort of a ceramic coating there. Okay, that's how most elements are made anyway. And this had some very fine, when I pressed it out, like white powder came out. And you can see some of the insulation started to break off. Now, this is probably what I'm doing is all for nothing, right? Because this might short circuit now to the steel. If that happens, it's not good, even if I'll be able to spot weld this. But for the sake of another project that I'm doing, a spot welder, which many people have made, but the spot welders that people have made on YouTube, they're just basically gonna spot weld the batteries, the terminals on the batteries. My one is going to be a bit different. I want to be able to make something like that I can spot weld that wire there. So I will try to make a project regarding that. But this is a stapler here. This is a paper stapler. You can see it's the staples. And that's the other half of it. I took the whole stapler apart and I was thinking of modifying this, which, not just thinking, but I'm actually doing it. So where the staples goes in here, I removed all the inserts and I fitted this brass neutral connector on switchboards. And this is a brass fitting here, where normally you put the wires and you screw these terminals. Okay, but I want to see if I'm going to be able to spot weld that with a spot welder. So I'm still in the process of making this unit, and this is going to go something like this, and still a lot of work to be made before it. I'm not sure if it's going to work, but and that will be stapling, spot welding something like that wire there with this terminal. This is a contactor from forklifts. It's actually, I kept this contactor for many years when I used to repair forklifts. If I can't spot weld this, I can buy an element. They're very expensive, close to $100 in Australia just for that, just for this. But for the sake of finishing the project, that's what I want to do. So I'll still want to see if I can spot weld and fix the element. Hopefully good enough until I finish the Weller project. Okay? So once I get the spot welder running and be able to spot weld this, if I'm successful, then I'll continue on. If not, I'll have to get a different element, a brand new element or something. All right, so here I have the spot welder stapler that I modified, and I finished it up. I probably might add a micro switch here, but I'll have a video regarding the spot welder transformer here, which is the microwave transformer. And the reason for me building this is so I can fix, or try to spot weld the Weller element, which is here, the soldering iron element, which this wire here has broke off one of the terminals on the element. It's got two, obviously, and it's actually spot welded. So I want to try to repair that. And I'm not sure if this element is going to work in the end, because the insulation, the braided insulation on the ceramic braiding on the nichrome wire, it started to come off, so it might short circuit onto the metal. But anyway, I will try it. And so I'm in the process of testing the spot welder, okay, hand spot welder here, for verifying wire. Now I have done a test, and this is nichrome wire, 0.25 millimeters, the same size as the element. So the element of the Weller is 0.25 millimeters, but it's got a braid on it. And just might as well here, I'll see if I can show you on this microscope here. Let me set that up. So this is the nichrome wire I spot welded, and if you could see there, it actually have melted the two parts together. That's from one end, and you can see the spot weld there. So you can see how the terminal is not in line anymore, this one. That means it actually have cut off but welded at the same time. Now that was done with 40%. Okay, let me zoom out. That was done with 40% of power on the triac, on the waveform. So I'm using one of these cheap Chinese spot welder regulator here, controller, and that was done 40% of power. Now I've put it to 38, and was done with 2 cycles. So okay, so that's under there. Press the button, and it is stuck. But we don't know how good that is, so let's see on the microscope what we're going to read. Okay, so that's the spot weld there. You can see the metal right. Which it might be good enough. Might be good enough. It didn't cut the nichrome, but you can see that there is a bond there. Okay. Now the other part that I could try is if it breaks off. If I try to break it off, it's very delicate. No, it did break off. There you go. So I think it needs more current again, and I might maybe, let me, instead of putting more current, I'll expand the I'll give it 3 cycles. So instead of 40 milliseconds, I'm going to give it 60 milliseconds at 50. Okay, let's try that. Okay. The hard part here, of course. And of course, let me set the inrush current as well. So I'll read that. Inrush current. And let's see if I'll be able to get this right. Okay, so I've got it in there. Okay, press the button. Okay, it spot welded it, but let's see in the microscope. Let's see what we got. Try to get this in focus. And on this case, it didn't solder on the, it didn't spot weld on the flat surface, but you can see this time it actually have bonded. No, but it, yes, but it broke off almost too much. You see, almost too much. So that broke off, but that part stayed on. So maybe 60 milliseconds, and maybe go back to 45. I'll go 45. Oh yeah, and have a look. Sorry, I haven't looked at that. The inrush current now, we got 194. You see, 194 amps, which could be still too high. So let me bring this down to, let's try 40. Let's go back to 40% and 3 cycles, which is 60 milliseconds. Let's try that. So let's do the inrush current measurements. So you see that because I increased it to 3 cycles, the current, of course I did go to 50, so the other one was with 50. So let's try now. But it is spot welding it, like see that's, it's stuck. I went back to 108. Okay, so you see it was the current, it was the percentage on the current. When I went from 40 to 50, the current's gone up to, what was it, 190 or almost 200. Now I've got 3 cycle at 40, it still gave me 108. So the cycles maybe is not really affecting it that much. Okay, now let's see what we got here on the screen, on the microscope. This is the new spot weld. This one looks like, hang on, it's hard to move it and keep it in focus, yeah? You can see the spot weld there. So the wire is on the top. So I'm not on the bottom. The bottom is there. You can see it's reflecting the light. So it's this one we're talking about. So from underneath it doesn't seem like it burnt in, but from the top it does look like it melted into the nickel, or this wire here, the flat part. So let's see if I can break that off this time from here. Now see, it broke off. That tells me that's very close. If I increase the current, it's going to burn it right off. So you see, it still left this part spot welded. Now let's see if I can break that part off, or how it's going to break off is the question. So let me zoom out a bit. Okay. Okay, the camera decided to put the light on. I didn't know I had the LED on the camera on, so it probably wasn't helping. Zoom into the screen, that's better. Focus on the weld. Now we can see the spot. I'm trying to grab with the tweezers here. That part is very solid. In actual fact, let me, instead of by hand, I think that's pretty good. That is strong. So you see, that is one piece. So I think 40% with my transformer and 3 cycles should work okay. So of course, if I had the same nickel or whatever this strip is made out of, I can do more tests, but this is, I need this for the soldering iron itself because it belongs to it. So in actual fact, where I spot welded here is where the connection of the terminal of the wires connect. The element section will solder on, will spot weld on here. So, you know, I think this might work, this spot welder that I made with the transformer. So I'll see how I go try to spot weld the element now. Okay. Okay, let me just check on the microscope. This is what I got on the microscope. It doesn't look like it welded enough. It's stuck there, but I don't know how good it is. Just trying to look on the side. I reckon I should give it another weld. I'm gonna have to give it another go. It doesn't still looks like it's good enough. I've increased it to 50% now. What I think is happening is that because it's an old wire there, it feels like it's dirty and it's not making good contact. I probably really should have tried to clean it up, but now. And the inrush current here, I've measured 177 amps. And I had to increase it to 50%. So you see, before at 50%, I had almost 200 amps. So it's definitely not making good contact. So I'm going to increase it a bit more in the current, 55%, and try it again, because to me, I'm still not getting the right weld on it. So anyway, I'm trying to see how strong it is. It seems pretty strong. Trying to pull it apart. Might be good enough. I wish I saw a bit of more melting, you know? One more go. One more go. Okay, so I put back the insulation on it, which is this one here. I put a bit of Kapton tape. This, of course, cannot take the temperature of the iron, but it doesn't matter, because just to hold it in place until I put it in the other sleeve here, which that fits in there. But I want to test to see if any of these terminals here are shorting to this metal, because how I said, this element, focus, this element, it's got a ceramic braid on it, which, you know, over the years, because it's old, it actually started to come off. So you see here, the wire I spot welded is bare wire now, and it might be touching to this, but I'll check it to see how it is right like that, if it's touching to the metal. Okay, in the end, this is probably might not work, right? But just for the try to finish the project, I want to see if I can get it going. Now, what I intend to do is to put some ceramic exhaust compound here, okay, to try to set it. I'll paint it on. It's an exhaust cement that you put on the exhaust manifolds on the engines of the cars, to try to insulate it, and that little bit of bare nichrome wire doesn't touch to the steel. But hopefully, when I test with the meter, if that's not shorting out already into the steel. If it is, I might have an issue, and it might be no good. But the issue with the with this was that the metal was burnt. It wasn't clean. If that was clean, and it's very hard to get it clean, because I didn't want to damage the nichrome wire braiding more than what it already is, because to clean it, you need to scratch the surface of the metal, of the nichrome wire. And because of that pitting, and it's been old, it wasn't making good contact, so it was having high resistance between the two metals. Therefore, you know, the weld it's not as good. But I tested it, tried to pull it apart without too much strength, and it didn't come apart. So It might hold. It might hold, but how I said, repeating myself here, I want to test the insulation here between that and the steel. Okay. Okay, so I got the multimeter here set on ohms. It's actually on mega ohms. And I'm going to test. So make sure you see I'm reading there across the steel. 1 ohm, 0.6 ohms, okay. So I should get something onto the metal if it's shorting on the element wire. So I'm getting nothing, which is a good thing, because it means I have well, that's saying open load. It's not shorting. I haven't got mega ohms resistance. And if I try the other terminal, okay, I'm also getting nothing. Now I should get around 12 ohms across the element itself here. And there you go, I've got 13 ohms there. Okay. 13 ohms. I wonder if that spot welder is strong enough that it's making good resistance. But it is, because it wouldn't pull apart. So hopefully it will not come apart, because that's the only chance now for repair. Once I put that exhaust compound, we won't be able to fix it again. So then you would need to buy a new one. I would need to buy a new one, which is very expensive. But you see, I'm measuring 13 ohms and nothing on the casing of the element steel on the pipe here, which is a good thing. Okay, today I've got this exhaust cement, sealant cement. It's from China. I don't know how good it is. And here you can see the element, and you can see it's got a webbing on it wrapped around the element, the nichrome wire, but you can see how some of it has come off. Okay, so what I'm going to try to do is paint this on with this stuff. So I don't know if it's going to work or anything like that. We'll see how we go. Okay, let me open the unit. Okay, so I'm going to put some on this paper here, if it comes out. And I think that's already heaps. It's a grayish material. Okay. And I'm just painting it on with a brush. Sorry, I went out of the screen there. Just got to make sure I'm not putting too much. Maybe. I'll just show you this way, not on the microscope. So let me take a look at it and make sure that it's okay. All right, so from what I can see is that it's already drying up. So I think I'm gonna have to press it in. Otherwise it's gonna dry. So we'll see how we go. Has to press it in more. It's like an epoxy. I think I've just wrecked it. I could see the element here came up. Part of the element. Can't believe that happened. So the more you try, the more problems. I'll just have to pause it. Okay, bad news. The element is not good. This cement here, I've realized is conductive. So everything is shorting out to the steel now. And I damaged the element while trying to get it out. The stuff dried up and it started to unwind. So just to show you here on the meter, Okay. If we touch the steel now, and the element, I'm reading resistance 100 meg, 30 meg. It's not making good contact, obviously. There you go, 0.5 meg. So 500k, it's not good. Plus I damaged it now because, as you can see here, there's the element there started to unwind, so just might as well unwind it all, and it's not good. So I've damaged it, and I'm gonna have to buy a new one. Now of course all the insulation is gone, and all it is just left there. This stuff, I didn't realize it's conductive. So there you go. It was all a waste of time, you know. I did have a feeling it might not work, but I tried. Yeah, I don't think I'm going to waste any more time with it. Not unless this was short-circuiting, but even if I show you here, that's the paste there, the cement. You can see how the meter is reading 0.91 meg. Okay, so it's conductive stuff. I didn't realize. Probably should have used a different brand. See, these Chinese products, I thought it was going to be a ceramic material, but it wasn't. There's the element there.